this frame here, you might notice that these cross members, these like 40-20 cross members, they weren't in my first sketch that we all did together, but I've added them in now, and I've also put in these supports. And these supports, I've kind of skipped the end product here, but they were actually made due to the results from the simulation. So we obviously don't have time to talk about how simulation works in a whole tutorial on simulation, but there's two big differences of how I can simulate this specific model here for a metal frame with wooden planks going across the top. One way is to treat these all as beam elements. And if I go, see if I can pull up the mesh here. Treating these as beam elements will basically slice them along the axis and turn them into little chunks like this. The advantage of this is that this is incredibly fast to run. And at this point, I'm going to switch over to my slides here. Okay, it's incredibly fast to run because we're not actually looking at the individual geometries of all of those members. So that 2020 aluminum extrusion is brutal on standard FEA because of all the small details in those T-slots. It's basically a really long, skinny material where if I want to fill it up with tetrahedral elements, which is what I would normally use in an FEA study, it's going to create so many elements that the solve time jumps up very quickly. Beam analysis, when I ran this on my computer, it's effectively a 0 solve time. The counter doesn't even get up to 1 second. There are limitations here, so I can't simulate contact. So at the edge here, you won't be able to see this in the picture, but over here, there's a little bit of a red hotspot. Basically, the plank there is allowed to pass through the metal support member that's sitting right under it because it's not calculating that kind of edge-to-edge contact as a joint. So beam analysis is based off of joints where when you have a corner or a T meeting up in your weldment, it will basically stitch them together at that point. But it also leads to some inaccuracies at those edges. The alternative is to use our standard solid analysis. I was able to simulate this in 10 minutes, but this can basically be open-ended in terms of how long you have for the solid analysis to run. So one of the studies took 10 minutes, the other one took 45 minutes, just depending on the mesh density that you want to deal with. The advantage here is I'm able to get a lot more realistic interactions. So I can have contact for the planks in the middle where they're just resting on those cross members. I can have bonded for the wood planks at the edges where they're basically going to be screwed into the wood. I'm not simulating the actual screws here or using bolt connectors because that's not what I'm concerned with. I'm concerned with the deflection of the model kind of in the middle if I were to load this up with 200 pounds of equipment sitting on top of it. So it's a much higher resolution study. That can be a good or a bad thing, right? It can give us a lot more results. And actually, I can see here the separation. So I have that 40-20 on its long side in the middle. So it's much stiffer in the middle than it is near these sides here. So, but it does take a lot longer to run. So if I can leave you guys with one thing for FEA regarding this model, I would start out with a beam analysis almost every single time, just to do a quick sanity check of, does this model even make sense? If the deflections are 10 times greater than what I expected, I should be going back to my model and looking at that, seeing what's going on with my design before I even move on to a solid analysis. Because for something more complex, I really don't want to load something for 3 hours and then come back and see that my model not only is going to fail, but it's going to fail so horribly that I probably should have known that anyway. So beam analysis, it's almost like a really good kind of napkin calculation before you invest a bunch of time into a solid analysis if you deem that necessary. Okay, so I know we're a little bit over time. Just quick summary page there for you guys. And then as we wrap up here, I'm open to any questions if you guys want to stick around and ask, or if you just want to mingle around. I don't know if there's anything planned for after this, the raffle. Shell analysis to a lesser degree. It's kind of in between solid and beam. So beam is really fast, solid's really slow. Shell is going to be in the middle. You get a little bit more functionality with shell as well.